Welcome you students. In this video lecture, I come up with another question from projection of line. Okay, so this is the given question for us. A line measuring 80 mm has one of its end 60 mm above HP and 20 mm in front of VP. The other end is 15 mm above HP and in front of VP. The front view length is 60 mm. Draw its projection. Okay. So now we shall try to extract the information from the question. Okay. So I can take the given data. A line measuring 80 mm. It is saying about the true length. There is no say about the line as A, B or P or Q, something like that. Okay. So here I am going to denote as AB, line as AB, which is given as 80 mm. Okay. And next, one of its end 60 mm above HP and 20 mm in front of VP. That means one of the ends, again take the end as A, which is 60 mm above HP and 20 mm in front of VP. Okay. What about the next? The other end is 15 mm above HP. Other end in the sense it's B, which is 15 mm above HP and in front of VP. Okay, there is no clear say where it exactly located. It is given as a clue. It is going to be where? In front of VP. Okay, so in front of VP. Right. What about the next? Yes, the front view length is 60 mm. Front view length is 60 mm. Okay, fine. So see here 1, 2, 3, 4 and 5. We have 5 data. It is more than enough to conclude the final front view and final top view. Right, fine. So we shall start our work. Just remember in your mind, whenever you are starting your projection works, you need to find, that means your first preference should be finding all the 4 odd locus, right? Okay, fine. Just go with the reference line, HY, we know as per the first angle projection, above the HY, it's VP and below the HY is HP. Okay. So what about the locus? Yeah, we can start with the A. It is given 60 mm above HP. That means above in the sense it's captured above the reference line, right? Okay. So take 60 mm with your scale and specify dots from this reference line. Both the ends you can specify it and go for a horizontal line passing through those points. Okay. We get. So this is the locus of A dash, since it is a front view A dash. Locus of A dash. What about the next? 20 mm in front of VP. In front in the sense it captured below the HY line. So measure 20 mm approximately here in the same manner. Measure it off and go for a horizontal line passing through it. So this is the locus of S A. Locus of A. Fine. So now we got the locus of A dash and A. It is more than enough to specify the one end in the front view and the top view, right? So here in the left extreme, so one end. So in the left extreme, I am going to keep A dash. So in the projector of A dash, our top view A will be located, right? So go for a projector line. It should be a very thin. When you are doing so, it intersects with the locus of A. It is the point A for us. Okay, fine. So let me move to the next end. It is given 15 mm above HP. 15 mm above HP. So here it captured above the reference line. Take the measurement. Approximately I can say here it comes the same manner. Here it comes. Go for a horizontal line passing through the picked point. I can say this is the locus locus of what? B dash, locus of B dash. Okay, fine. So do we have another locus here? No, right? It is specified. It's gonna capture in the in front of VP, but there is no exact measurement, right? Okay, let it be. So next, one more data we have, front view length. It's mentioned as 60 mm. Think about the nomenclature which we have given in the introduction part, especially in the projection of, that means when the line is inclined to both the planes. I hope if you have better understanding, I have shown you that I can say the FVL, front view length, just it is located in the locus of A dash. If you are not remembering, just turn out to the page and see. You can see the front view length just located on the locus of A dash. Okay, so this measurement should be captured over the locus of A dash. So it's 60 mm. So keep your scale as this manner from A dash, just to have a measurement. I hope you will get here. So this point is B2 dash. This point is a B2 dash. This is the front view length. Front view length. So think about the general problem. How we get the front view length? How we get? Yes, from the true inclination in the top view, from the projector, we get the front view length. Am I right? So here we have the front view length. Just we're going to reverse the things. That means from the B2, we're going to extend the line. Extend the line. We don't know the exact location. We don't have the locus of B. So just we are extending to maximum. Now we have the true length as the 80 mm, right? So just measure it in your compass and keep it A and go for a cut mark in the extended line from B2 dash, so that you will get B2. You will get B2. If you connect A to B, you can find the true inclination in the top view. Pi. Okay. If you draw a very good horizontal line, 0 degree line, just passing through the B2, we get locus of B. Now see, all the 4 locus we have. So simple. Now we have the true inclination, the top view, and before we have the front view length. So next, what is the step? We have to find the true inclination in the front view, right? Yes. So we know it's a 80 mm. We have all the locus. So just measure it in your compass. Keep at A dash and just look for the locus of B dash. Since the B dash locus is minimum when compared with the locus of A dash, it is here. So just give a cut mark with the 80 mm. Approximately you will get here, right? So this point is B1 dash. It is not the final front view, it's a true length. Am I right? So this is a B1 dash. If you connect it, you will see the true inclination in front view, theta. What is next? S. Just extend this line, just give the projector line to the next locus, that means A. So it will come like this, so that I will get B1. I hope what formed? Yes, you will get the top view length. A to B1 is a top view length. Now we have the front view length and top view length. What is next? S. We have to introduce the rotating line method. It is so easy. Let me start with the top view length. Just measure A to B1 in your compass. Keep A as center and go for an arc and the locus of B. It comes like this. It comes like this. Okay. So at that time you will get a cut mark and the locus of B. It is your point B. If you connect line from A to B, it's your final top view, which is a dark line. You will get beta, apparent inclination in the top view. Okay. So our route, flow of the line comes like this. Am I right? Yes. So now we completed now we got the final top view. What is next? Is final front view, right? For which measure the front view length in your compass A dash to B2 dash, and just keep A dash as a center and just have a cut mark to the locus of B dash. It is here, so that you can give a cut mark as this manner, okay? At that time you will get intersection point in the locus of B dash. It is your final end point in the front view. It's a B dash. If you connect A dash and B dash, you will get a final front view length. Final front view, okay? Final front view, right? So this is your apparent angle alpha in the front view, and in order to check whether your projection work is right, what we can do is just look for the end projector. That means if you connect B dash and B, it just in a 90 degree or perpendicular to this HA reference line, okay? So we got the final front view and final top view. In the projection of line, two things should be dark, that is, one is a final front view and a final top view. What is next is we have to capture all the measurement in your diagram, right? So we have 5 data. Check whether we have captured all the 5. Let me start with the true length, which is 80 mm. So here in the bottom I am going to capture the true length measurement, for which take the dimension line 90 degree to that line and go for a parallel line and capture arrows at both ends. It's a filled one, and write above it as 80 mm, okay? Fine. And next, so locus are there, right? So for that, here we can give, so I'm going to take a line 60 mm above. So here is it, and 20 mm in front. Here it captures right above your line 60, and here is 20. One more thing is there, locus of B, which is 15 mm in front of VP. So here we have space. Since it is a smaller one, you can keep it inside. So here you can place it, capture with the end arrows, and write above it as 15 mm, right? So I hope all the four we have captured. One more is remaining, front view length. So where is the front view length? Yes, here we have, right? So extend the line, get the 90 degree line, okay, and just have a parallel line in order to specify the dimension, and make the filled arrows at both the ends and write above the line as 60, okay? Fine. Next, the important thing is we want to display all the dimensions, okay? We have 7 terminology here. We should give a clear detail about it, okay? So at the bottom you can make a box and write AB, which is given in the question, 80 mm, no worries, and then about true inclination in the front view and true inclination in the top view, pi. Theta can be get from here, so for which you can keep your protractor as this manner, okay? As this manner you can keep and read it from 0 from this line and measure it, and what are the value you are getting you can write here, okay? You will get in degree. The same manner do for here. So keep as this manner, okay, and read it off and measure it, get the value, you will get it in degree. And next, apparent angle alpha and beta. at the same manner, with the same position, how to measure it, and you will get the things alpha and beta. We get n degree. Okay. So two more things are there. That means final front view and final top view. Distance between A to B, you get n mm. Can make use of scale to measure it, and A dash to B dash, you will get it in mm. You can make use of scale to measure it. Okay, here it is, and one is here. Fine. I hope you got the idea how to work with the projection of line. Okay, fine. Thank you.